Have you ever stopped to think about what's really holding your favorite app together? It's way more than just lines of code. See, underneath the surface of every single piece of software, there's a hidden world, a unique map of its data. So today, we're going to take a journey through these maps. Let's dive right in.
So if you look at this map, you'll see it's not just one big country. It's got all these different regions. Each one represents a completely different way of organizing information, what we call a data model. And each has its own rules, its own strengths, its own trade-offs. So the big question is, what are these different lands, and why on earth do developers choose one over the other?
Well, at its heart, a data model is really just an abstraction. It's a clean, simple interface that hides all the messy, nitty-gritty details of how bytes are actually stored on a disk or in memory. And this is so crucial because the data model you end up choosing doesn't just tweak your code. It literally shapes the way you think about the entire problem you're trying to solve. All right, so our first stop on this journey takes us to the oldest, most established kingdom on the map, the relational empire. This is the world of neat tables, rows, and its incredibly powerful language, SQL. It's hard to overstate just how long the relational model ruled the world. It was first proposed way back in 1970, and it just completely took over business data, and then went on to power pretty much the entire early web. For decades, if you had data with any kind of structure, you used a relational database. It was the undisputed king, no question.
So how does it actually work? Well, let's take something like a LinkedIn profile. The relational approach literally shreds this document into little pieces. The person's name goes in one table, their job history goes into another, their education into a third, and so on. And then they're all carefully linked back together using these unique IDs. And right there, that's the whole magic trick. It's an idea called normalization. The entire goal is to get rid of duplication. You store the name of a company or a school in exactly one place. So if, say, that company changes its name, you only have to update it in one spot. Just one. This makes sure everything stays consistent and super tidy. But, every empire faces a rebellion, right? And the strict, rigid order of the relational empire was no different. Welcome to the flexible frontier of NoSQL, a new land that was born out of a desire for something, well, less rigid. So what kicked off this rebellion? It was really a perfect storm of things. The web was growing at a crazy pace, and developers needed databases that could actually scale with it. Plus, there was this huge movement towards free open-source software. And let's be honest, a lot of developers were just getting fed up with how restrictive the old relational schemas felt. Now check out how the NoSQL document model tackles that same profile. So instead of shredding that profile into a million pieces, it keeps the whole thing together in one self-contained JSON document. It's basically a tree with all the user's information, jobs, education, you name it, all nested right inside. And this is huge. It looks almost exactly like an object you'd see in the application code itself. Developers absolutely love this. Okay, so the big win here, the real game changer, is this concept of locality. Because everything you need for that one profile is all in the same place, you can grab it all with a single query. No more complicated joins, no more piecing things back together. Think about it. If you usually need to show that whole profile at once, you can just grab it in one go. That can be a massive performance boost. All right, so let's put them side by side for a second. On the left, you've got the relational empire. Structured, normalized, super consistent. And on the right, you've got the document frontier. Flexible, self-contained, and all about locality. This one picture, it really nails the fundamental trade-off at the heart of all this. And this brings us to a really powerful way to think about the difference. The relational model is what we call schema on write. It's kind of like static typing in a programming language. The database enforces a super strict structure before you can write anything. Document models, on the other hand, are schema on read, which is a lot more like dynamic typing. The structure is flexible, and it's really up to the application to figure it out when it reads the data. Okay, so that's all well and good, but what happens when your data isn't a neat little document? What if it's more like a giant tangled web of connections where everything is potentially linked to everything else? Now that is a question that neither of those first two models answers perfectly, and it leads us right to our next stop. Well, that exact question leads us to the next region on our map, the web of graphs, a land that is perfectly designed for navigating through complex, interconnected data. It's a classic story, right? You start building an app, it's all nice and simple. But as you add more and more features, your data just gets tangled. That simple user profile can suddenly turn into this complex web of many-to-many relationships.
And at that point, trying to cram this messy web into neat tables or clean documents just starts to feel, well, really awkward. The thing is, once you start looking for them, you see graphs everywhere. Social networks, of course, that's the classic example. You, your friends, and the connections between you. But they also perfectly model things like the entire World Wide Web, road networks, or even those recommendation engines that suggest what you should buy next. And what's so cool about graph models is how simple the core idea is, but how incredibly powerful it becomes. You've really only got two main things. You have vertices, which are just the objects, like a person or a city, and then you have edges, which define the relationship between them, like lives in or works at. And both the vertices and the edges can have their own properties, which gives you amazing flexibility. Okay, but how do you actually talk to these databases? How do you ask them questions? This brings us to a really important idea, declarative versus imperative querying. With an imperative approach, you have to write code that tells the database step by step how to find what you want. But with a declarative language like SQL or the graph language Cypher, you just describe what you're looking for and you let the database figure out the best way to get it for you. You've probably used declarative languages without even thinking about it. Just think about CSS for a website. This one little line of code just describes a pattern. It says, hey, find me a paragraph that's inside a list item with the class selected and make its background blue. You're not telling the browser how to find it. You're just describing the pattern of what you want. It's so clean. Now, contrast that with the other way of doing it, the imperative way. Look at this JavaScript. You're writing loops, you're checking conditions. Man, it's so much longer and honestly way more brittle. If the page structure changes just a tiny bit, this whole chunk of code could break. The declarative way is just better, and the same is true for databases. Okay, so we've been on quite a journey, haven't we? We've explored the structured relational empire, the flexible document frontier, and the interconnected web of graphs. So how do you pick the right path for your own project? And here's the big takeaway. There is no single best map. The right data model depends completely on the shape of your problem. If your data is highly structured, full of one-to-many relationships, the relational model is fantastic. If it's mostly self-contained documents, the document model is probably your best bet. And if it's all about a web of connections, the graph model is just the most natural fit. And this is really where modern software development is at. It's not about one model winning out over all the others. Instead, developers now embrace this idea called polyglot persistence, which is just a fancy way of saying you use the right tool for the right job, even if it means using several different types of databases in the same application. So the next time you sit down to build something, before you write a single line of code, take a second to think about that hidden world, that map of your data. Think about the relationships, the structure, and the story it needs to tell. And then ask yourself, what kind of map are you going to draw?